Today we are going to look at the North Carolina Math 1 released questions 4, 5, and 6. The directions tell us that these would be gridded response items, and they require you to write your answers in the boxes provided on your answer sheet. If you're taking the online version of the test, you will either have to enter the answer into a box or drag and drop the answers. Okay, let's take a look at number 4. A line y equals mx plus b passes through the point 1, 6 and is parallel to y equals 4x plus 6. What is the value of b? So again, we always want to plan our approach and highlight any of the key information in the equation. So I see right away that we're working with a line, and we are working with slope-intercept form. Okay, and just recall that m in this equation is where we write our slope, and b is where we write the y-intercept. They also tell us that the line has to pass through a given point. Our given point is 1, 6. And remember, a point is a value for x and y. So a point is an ordered pair. The first number in that group is your value for x paired with your value for y. They also tell us that this line needs to be parallel. And we know that if lines are parallel, they share the same slope. And they give us the equation the line is parallel to. And in this equation, the line is written in slope-intercept form, so I can easily identify that 4 is the slope of the given line. Okay, so we know that our slope also needs to equal 4. That is a value for m. And we also have a value for x and y, the 0.16. So what we're missing is the y-intercept. We are missing the value of b. And notice that is what the question is asking us to find. What is the value of b? So I'm going to write down my slope-intercept form, y equals mx plus b. Anytime you have a formula or an equation and you know all of the values except one, you can substitute the values in for each variable and then solve for what's missing. So we know our y value equals 6. We know that our slope value equals 4. And we know that our x value equals 1. So we are going to use this equation to solve and find our y-intercept. So on the right side, we can simplify our multiplying. So 4 times 1. And I'm just going to recopy the 6 equals. 4 times 1 is 4 plus b. And now we're just trying to isolate the variable. In order to get b by itself, we need to undo and move that positive 4. So we will subtract 4 from both sides. On the left side, 6 minus 4 equals 2. On the right side, 4 minus 4 equals 0. So we get 2 equals b. You could always rewrite this with the variable in front. B equals 2 is also equivalent. Since we're taking the online version of the test, you would probably see a box for you to enter the answer. You do not need to enter the b equals. You only need to enter the 2. Okay, for number 5, it says we have 2 functions are shown below. F of x equals 1/2 times 2 to the x power, and g of x equals 5x plus 2. So the goal here is for students to recognize that this is an exponential function. Notice your variable x is the exponent in the equation, and this is a linear equation. We know this is linear because the variable x has a degree of 1. Notice we have a slope of 5 and a y-intercept of 2. In the exponential equation, we have a y-intercept of 1/2, and we're multiplying by 2, so that means we're doubling each interval. Now the question says, what is the largest integer? So I like to highlight those keywords. We are looking for the largest integer value such that f of x, so I'm just going to kind of make some notes here. F of x, remember, is the exponential function, is less than or equal to the linear function. And we've really looked at a lot of exponential and linear functions this year, and we know that exponential functions increase very rapidly and eventually will increase faster than the linear function. We are starting with a higher amount in the linear. Notice we're starting with 2, and we're just going to add 5, add 5, add 5, because this is our rate of change. So that tells me we're just adding 5 each interval. In the exponential function, we are starting with 1/2, and this 2 tells me that we are multiplying by 2 each interval. And we're trying to see, when does the exponential, what's the largest integer value where the exponential function is less than or equal to the linear? So I would make a table for each of your functions, okay? So I'm just going to make a table for my linear function. I'm going to draw my tables horizontally just for space. You could also draw your tables vertically. Okay, and I'm going to start both of my tables at 0, and we know in the linear function, so if this is my linear and this is my exponential. So I know in my linear function, my starting amount is 2, and each interval, all we're doing is adding 5. So the next interval, 2 plus 5, 7. The second interval, 7 plus 5, 12. The third interval, 12 plus 5, 17. The fourth interval, 17 plus 5, 22. The fifth interval, 22 plus 5, 27. Okay, and you may see a pattern. You're going from 2, 7, then 12, 17, 22, 27. So the numbers, the 2 and 7, you'll see that pattern in your y values. Okay, in your exponential function, remember we're starting with 1/2. You could write that as a fraction, or you could also write that as a decimal. I wrote that in the wrong spot though. Let me go back. Sorry about that. I just scrolled. So when x is 0, because that's our starting amount, the y value is 1/2, and we are doubling each interval. So if we take 1/2 and multiply by 2, that is 1 whole. 1 times 2, 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So I will need to go out further. I may have to erase this part. Okay, then if we continue, in the sixth interval, 16 times 2 is 32. And by the seventh interval, 2 times 32 is 64. Okay, I'm going to go back and extend my linear intervals. So again, remember the pattern was just adding 5. So in the sixth interval, we would have 32. In the seventh interval, we would add 5 more, we would have 37. Now notice this says less than or equal to. So if we look at where these two functions are equal, you will see that when x equals 6, in both functions, we are getting an output of 32. So what is the largest integer value of x such that the exponential function is less than or equal to g of x, so the answer is 6. Again, this would be an open response question. You would probably have a box to type your answer into. Okay, number 6 says a company models its net income in thousands of dollars with the function f of x equals 9x squared minus 54x minus 144, where x is the number of units of its product sold. How many units of its product does the company need to sell in order for the net income to equal 0? Okay, so a couple things I noticed right away as my eyes are drawn to that equation. And I notice in this equation, the highest degree is 2. So we are working with a quadratic equation. We are wanting to set the quadratic equation equal to 0. So that means we are looking for our zeros of this quadratic. So I'm going to say 9x squared minus 54x minus 144 equals 0. Now, anytime I have an a value greater than 1, I'm going to check for a greatest common factor. So I know 9 is divisible by 9. I'm going to also ask myself, is 54 divisible by 9? And the answer is yes. And 144, I'm not really sure, so I'm just going to come over to the side and check this. So let's see, is 144 divisible by 9 evenly? So 9, of course, does not go into 1, so we're going to look at the 14. 9 goes into 14 one time, and then we're going to find the difference. So 14 minus 9 is 5. Bring down your 4, and 9 goes into 54 6 times. So 144 is also divisible by 9 16 times. So step 1, we are going to factor out the GCF. And we have identified the GCF is 9. So divide by 9, divide by 9, divide by 9. So pull the 9 out. That leaves us with x squared minus 6x minus 16 equals 0. We still have a quadratic because notice inside the parentheses we still have our x squared. So we're going to see if we can factor further. So again, we're going to keep the 9 on the outside. I know to get the x squared, we multiply our x times x. And now we're looking for factors that multiply to give us negative 16. And the same two factors must add to equal negative 6. So this tells me my signs needs to be different. So I need one positive, one negative. This sum tells me the larger factor needs to be the negative. So let's write out our factor pairs, making the larger factor negative. So we have positive 1, negative 16. We have 2, negative 8, 4, negative 4. And now we're looking for the pair that will add to give us negative 6. So 1 minus 16, that's negative 15. So that is not it. Okay, 2 minus 8 equals negative 6. So we did identify the pair of factors that will work. So one of these factors will have a plus 2 and a minus 8. Now those are the factors. We still need to solve to find the zeros. So we know to get a product of 0, we would have to multiply by a 0. The 9 will never equal 0, so the 9 is out. But this group, we could get a 0 if x is the opposite of positive 2. So this x would need to equal negative 2. This x value would need to be the opposite of negative 8, so x could equal positive 8. Remember, let's look back at the question. We have two possible answers. We have a -2 and a +8. How many units of its product, so I'm going to underline this, how many units of its product does the company need to sell in order for the net income to equal 0? So when we solve quadratics, sometimes the negative value is going to be extraneous. It's not going to work for the context of this problem. We cannot sell negative units, so -2 is out, and our best answer is 8 units.